Today's focus is going to be on the bearing cap. There are two of them. They start off looking like this, and they're connected to, I believe it came connected to one of the cylinder components, cap or God knows what, but it really doesn't matter. There are two, and the way I'm going to do it is just like lop them off, start with, okay, we're going to have to make two pieces out of that. What's important here? Well, the important details on this one would have to be this 499 dimension. You do not want that to be too big because it has to fit in the groove that you cut in the back of the frame. Bearing cap sits right there, constrains the crankshaft so that it can spin freely. There is a small protrusion, very small protrusion. I mean, it's right there on the drawing, and boy, I tell you, you got to look for it. It's right there, and without a bright light on these castings, it's really hard to see that. It's almost invisible. My first step is to remove all the flash. I'm going to take off all these burrs. I'm going to clean the gates from both sides, and then we're going to start addressing all the other features. I believe that the location of these holes in relationship to this little elevated boss right there is probably more important than the concentricity of the spot face to the through hole. Although concentricity will be established, the location of the holes to those constraining ribs right there is more important. Let's take the flash off, clean them up a little bit, and determine exactly how much material we have to take off of these surfaces, if any, and go from there. Let's do a mechanical inspection, see how thick everything is, see what the expectations are for the cut in the center, and that'll be my next step. If you're going to push this part up against a belt sander, make sure that the witness marks left from the sanding are not tapered, wedge-shaped. You want to see a nice even footprint like that across the back, and that'll let you know that you did a fairly reasonable job of equal pressure. Same thing on the sides. This was the large gate side, which is why it has a whole lot more cleanup. With the cast side having a draft angle to it, and the boss itself not having a draft angle, in order to clean up to the very bottom, it will affect the entire side. And this side, you can see we have a pretty good cleanup on the end, and the center is just demonstrating some of the draft going down into it. After checking the print, find out that I have about 32 thousandths of an inch to come off of this surface right here before we start all the other fancy work. And now here's my trick. Well, here's another thought for you. It's really nice to know if your part is square. How are you going to do that real quick? Gang up a bunch of 1, 2, 3 blocks like that and create yourself a pocket. Just pop it in there. If there's no movement, chances are the part is square. And this part is pretty square. I like it. It's square enough that I can trust it. Alright, quick and dirty square, guys. If you have 1, 2, 3 blocks, that's a great way to validate something done by eye, or in a pinch you want to know what you got. Do it that way. Alright, back to my trick. I am not going to cut these apart and hassle around with little pieces and little clamps and worrying about can't hold it. I'm going to flip it upside down on parallels, and I'm going to hold them together. These are going to remain intact throughout the machining operations because they're identical. Why not? I have to cut a track down each side and form that little rib, And if you want them exactly the same, we'll do them exactly at the same time. So that's how these are going to be handled. When it comes to drilling, I'm going to set my stop, find my center, and do my pattern, and then just flip the part around, put it right back in the same setup, drill my holes, flip it, bring it to thickness, and we are done. I could flip it over, put them spot faces on in the little 256 Oiler hole, which will happen. But I gave away my secret. I am doing them as one chunk. One chunk. Do not cut these apart yet. If you haven't already, don't do it. All right, let's flip them upside down the vise in the mill. Throw some chips. After you visually verify that your sanding operation has not thrown that center boss off center, and you are pleased with the alignment of the raised section in the middle to either side, which I am very pleased with it. I've got my parts now inverted on some tall parallels. They are still connected. There's two of them. I'm going to establish the center of that blank by sweeping the jaws with the indicator. Once I have a constant reading on both sides, I'm going to zero out my Y-axis digital, and we're going to call that the center of the world. Let's get with the machining. First operation is to completely deck the back side of this blank 1/32 of an inch, 0.32. That's just about 1 millimeter. And then we're going to come back and we're going to drop another 31 and put the 499 elevated center boss on. With the main flange thickness dialed in, next step is to put the 499 protrusion in the center. We're going to go another 31 thousandths deep. Just make sure that whatever you do, your stack height on your parallels allows you to do that from this finished surface to the jaw. You do not want to encounter that jaw. This time the center is completely finished. We're going to stay away from that because this entire surface here is going to end up being the thin elevated rib that's left behind after the bore goes down the center, and that bore is put in at assembly. Let's do the sides. If you have doubts about the measurement you're about to take on this elevated boss, this particular boss is best undersized than it is oversized. However, it must fit at assembly in the groove that you cut in the frame. So 499 is the call out, and we'll try to hit 499 on the money. .499 wide rib is established, 0.31 deep, And at this time, if you were to drill through these edges for the holes, you are going to encounter the parallels. I'm going to flip this part. Yeah, I want to flip it upside down and re-register one of these edges against the back jaw so I can drill it. But there is just no more accurate position than how it sits right now for putting those holes in that boss. So we're going to turn this camera off and think about this for 2 minutes and come back with the setup. And maybe I'll just drive the parallels out. We'll see. Hold on. I did decide to flip the part over. I went with a thinner parallel so I can drill through the part. I am now banking on the surface that I just machined. In order to keep a reliable, just kick the camera. Better than kicking the bucket, I guess. In order to keep a reliable center, I marked the edge that was against the stationary jaw. And when I flipped the part, I made sure that the same edge stayed against the stationary jaw. These parts will finish up at 625 wide each, and at this point I am going to start working end to end with these parts as individuals while they're still together. That means that this face right here is my zero face, the center of the part is my zero face. I'm going to move in 312, and that is going to be my 0 point. At that point I am going to move the X and the Y for the bolt pattern that I need per cap, and instead of jumping over here and doing it again, I will take the part out and I will flip the part. So yes, I will lose my red reference at that time, but if you've indicated this, you should be close enough with the clearance that are afforded you in the holes to the screw that this is still going to function 100% correctly. So I'm going to put the spot faces in first so the drill has a nice place to start, and let's see what happens. Before you start drilling with the drill, make sure that the drill will clear the parallels. With the machine turned off, go to your Y-axis max, well, maximum dimension that you're looking for to drill the hole in location, and check the clearance from the drill to the parallel. You do not want to drill down in that parallel. This camera angle looks a little shy, but we are about a 1/16 of an inch, 1.5 millimeters off of that little parallel that you can see, the dark one. So I'm good to go. I will center drill and drill all of these in a flip-flop operation, and then we'll set up for the porthole. Alrighty, interim progress shot. Spot faces look good. Thing cleaned up nice. There is a lot of porosity in this one corner of this part. That is not a problem with the spot face. alignment to the back. But we're going to find out how that alignment is when I cut the frame, right? Next step is to put the little oil holes in right here on these protrusions. Those are 256 threaded. And I guess in the absence of the bore, I could drill them first, tap them later, or just drill them, start the tap, and that way I have a guide hole to go through to when the time comes after the boring operation. The next feature in line is the small 256 it's a 256 thread for the oil cup. Make sure that you locate those little protrusions on these bearing caps. And for what this part is, I am going to sit this in here and move it back and forth. Oscillate it as you try to secure it. That will give you the closest reference in all three planes that you're looking for. But like I said, for what this is, it doesn't matter. Stick your 45-degree angle block in there. Rock your part till it seats. And the camera's right by my elbow. This is a hard one. There we go. And I am locking this vise with my elbow. I am pushing down on the handle with my elbow. Check your gauge, make sure there's no rock. Lock it down. I'm going to put a pin in my drill chuck, come down on top of it with the pin, visually align the hole, lock everything, drill and tap it. Actually, I'm just going to drill it. I'm going to drill it and I'm going to set my absolute to 0, 0. I'll move on to the second hole. I'll drill that one, same way, spotting it with the pin. And I'm going to take the digital readout, move it over to incremental, and 0, 0 that one. That way I have 2 0, 0 positions when I go back to tap it, and I will use a tap guide, not a T-handle. T-handle on a 256 tap is extremely dangerous because they are not a precision instrument. Let's do it. Should you care to, knowing that these parts are going to end up at 625, pick up the back side and move in 312.5. That'll put you right on center. I use a 160 diameter pin to visually find that little boss right there. I am going to drill both of them and tap both of them, and that should be the end of this part until it's assembly time. I'll take it. Swap out for the spring-loaded tap guide, run the holes. Going to use a Nirol spring-loaded tap guide. And I'm going to show you a little bench trick after I finish doing this. When we take this part over to the bench towards the end of the video, I'm going to give you a little tip on something you can do if you don't have one of those. Alright, 256, I'm going to run the thread in there about 200 thou, that's about 5 millimeters, and we're going to cut them apart. It is okay to drill these holes through this casting. The projected center line will miss the opposite side of the casting if that's what you choose to do. It is okay. And boy, I really like the way this stuff taps. It's a whole lot nicer than that nasty red copper bronze, whatever that other stuff is. I hate that other stuff. It's like titanium mixed with snot. It's horrible. Hate it. Feels good, but I don't like the way it drills and reams. Okay, right now my table is set incremental 0, 0 for this hole. Now I'm going to go back to the absolute position on the digital and move back to the other hole, which is the absolute 0, 0. A great application for the incremental and absolute functions of your DRO. It is just a cruel joke that this is a 256 hole for an oiler. I bet if you build one of these models and you break anything off of it, it's going to be one of these oil cups goes first. Just a hunch. When using a tap this small or smaller taps in general, please be sure that the body of the tap is running true to the hole. If you align it with something that doesn't allow you to assure that it's concentric, as the thread engages the material, the chances of snapping that tap off are much higher because the top half is running out like a little baby tornado and the bottom is straight. Something's got to give. That's why these tap guides are just fantastic. I love them. With the exception of the 625 width on these parts are basically done. I'm going to put a hacksaw across the center of them, cut them apart, bring them back over, and bring them to 625, removing that center gate on each half. Parts are separated, sitting on a single parallel. It's a 1/2 inch from the top of the vise to the parallel. These are 5/8 when they're done. I'm going to walk around the perimeter of this with a smaller end mill, so if there's any chipping to be done, I'm going to force the chip to the cast side and not to the outside. Hopefully this works. Well, I know it's going to work, but I'm going to show you. Knowing that I have approximately 1/8 of an inch worth of projection when I'm done, this is 1/8 of an inch parallel. I'm going to use it as a visual, you're close enough guide. I'm going to blow the part off, mic it, make my adjustment, and return the part to the vise. I'm going to do this with both parts. let's take the burrs off and put them on the bench, and I'll put a caliper on it and show you what we got. I like it. Final product. It is okay, like I said, to push this 256 hole through to the center. It will be removed at assembly. It will not hit anything important. Let's see what we look like. We're looking for 499 bosses on this thing. Wiggle it. 498. I like it. .498. Thickness, 11/64 on the thickness. That translates to 203 31 172. These ears should be 172. Close enough. Not bad for a cast registration. 172 and a half. I'll take it. 73. We're looking for 625 on the width. 625. 625. Not a bad little part. Do yourself a favor. Do not cut them apart until you're done with them. It's the easiest way to do it. Everything lines up. It makes it twice as fast. You don't have to goof around. Make sure that your end is square to the side. If you need to dust that for some reason while you are prepping the two-piece component, by all means do it. It's not going to hurt anything, and it's nice to know that the edge is square when you start that flip-flop operation going on in the vise. Alright, enough of those. I promised you a little gem, and here is the gem. Every once in a while you're going to have an oops, you're going to snap off an end mill or something. And what you need to do when you do that, instead of throwing it across the shop and sticking it in the wall, like I've been known to do, take it and sand it off and break the burrs on it and put it in your toolbox. This makes an ideal. Put it in your drill chuck and use that as a tap guide. Boom. Look at that. Like butter. Put this guy in your drill chuck, applying gentle downward pressure on the quill. Away you go. This is an ideal center. You want to put a little bit of oil, grease, Molly Lube, Never Sees, whatever in there. It works like a charm. You will find sometimes taps have a point on the end, sometimes they have a cup on the end. Put a point on this side. Now you have a point that you can drive the larger taps with, or you have a cup you can drive the smaller taps with. Cheap, dirty garage trick. There it is. Turn something into nothing, or nothing into something. Hope you enjoyed that. Joel Pye, Advanced Innovations in Austin, Texas. I'm out.